it's impossible to talk about particles without bringing waves. You already alluded to it. So let's formally define it. What are waves?
Well, that too is a word which is used in English in multiple ways. Yep. And we have to be very careful about that word. And it's hard to explain well because without examples. And the reason is that waves can do a lot of things. So let's first say what we're not talking about. You go to the beach and you surf a wave. Each wave is a piling up of the water, a crest of the water. There's a trough in front, there's a trough behind. That's what your surfer will call a wave. And most of us at the beach will call a wave. That is not the type of wave that we're referring to here. Mm-hmm. We're talking about waves in the way that a recording engineer might talk about a wave. For example, as I'm speaking, am creating a sound wave, which this is not a single piling up of the air, but a whole sequence of crests and troughs. So it's a wave that in the sense that it looks like this. It's not just a single bump in the water. It's the whole wave train, as we might say in English. That is what particle physicists mean by saying that a photon is a wave, or that light is a wave. We're not saying that light is a single crest. And so this is important because what you don't want to think of in your head is that you replace a little dot. You say instead of electron being a dot, it's this single crest. No, that's not it either. In general, an electron can do many things. It can have all sorts of complicated shapes, just like water waves, or wave in the singular, as a physicist would say, can have many shapes. Just as a sound wave, the sound wave that I'm making right now is very complicated. So the wave-like behavior of electrons it's not possible to draw it with a single picture, because waves can do all sorts of things. So if you want to really capture all the things that are wave-like about an electron, you'd really want to think about it in a lot of different settings and focus on the fact that, it can be this shape in this context. It can be that shape in that context. It has all this flexibility that waves have, and particles don't. So that's very important for light. If light had a fixed shape, we couldn't do all sorts of crazy things with it, and it wouldn't do all the wonderful things that it does in life. Same with sound. Mm-hmm. So in a sense, the wave-like properties of electrons and photons are used by nature it creates a flexibility for nature that allows for all sorts of wonderful structures. And in a sense, part of the wonderful thing about atoms is that they create a setting in which electrons can do all sorts of fantastic things, leading to a great variety of chemical and magnetic behaviors of ordinary materials.